It's going to take practice to read and interpret scatter plots, and that's what we're going to do in the next couple of slides. So let's start with a scatter plot that's pretty relevant for our time. It measures the average sea ice in millions of square kilometers over time. So as you have probably heard in the news, there's climate changes happening, and scientists have been measuring what's been happening to the ice that's at sea over the last few decades, and each point here represents a measurement. So for example, in 1998, if we look for 1998, here's 2000, so 1998 would be right here, and we draw the line up. This point represents 1998. So in 1998, there were approximately a little bit more than 0.8 million square kilometers. And I'm going to write square kilometers like this. So that's how you read a specific point on the scatter plot. Notice the scatter plot has a downward trend. And we're going to talk about the other descriptors in the next slide. So the direction, as mentioned, is downward. And that means we could call it negative. That's another way of describing it. Downward and negative mean the same thing in terms of scatter plots. So that means that as the years go up, the sea ice goes down. Now the form is linear. They follow a straight line. And I'm going to draw a circle around the points, or an ellipse around the points. There they are. And they're all contained there. There's a bit of width. They're not all lined up perfectly, like this would be a perfect relationship. They're not lined up perfectly. There's a bit of a spread. So I would say the spread strength is moderate. Are there any outliers? This is again a little bit subjective, but I would say that all the points are within that ellipse, and so there are no outliers. So when you are looking at a scatter plot, it's also important to always evaluate the source. And this scatter plot was created by Environment Canada, or the data came from Environment Canada. And that is a good indicator that the data is reliable and you can reuse it with confidence. The purpose of it was to measure sea ice levels over time. That's the specific goal. It may have been measured for a bigger purpose as well. It could have been to investigate climate change. So that would have been the bigger purpose, and this would have been one way to measure that climate change. So what did you learn? This is a very specific, very subjective question. It's going to be different from student to student. In my case, what did I learn? I learned that the sea ice is decreasing over time. What did you find the most surprising? Again, this is a very subjective question. What I found surprising is that at some years the sea ice level went up, and the next it went down, and then it went back up and down. So it wasn't a steady decline. This would have been how it would have looked if it was a steady decline. It was way more erratic. So I was surprised by how many fluctuations there were in the data. So that surprised me. What are the pros and cons of using this type of graph for this purpose? Well, the pros are it shows you the trends. And obviously there is a downward trend. In other words, the sea ice is decreasing. It can be used possibly to predict what's going to happen in 2016 and 2017 if the trend continues. So that's a pro of using this type of graph. Con is all the information that's missing. So it tells you everything about the sea, or it tells you something about the sea ice between 1970 and 2015, but it says nothing about what happened before 1970. So what happened over here? Was the graph going up the whole time, or was it flattened? So was it like this, or was it flatter before it started to decrease? So the cons is that it's limited information, and there's quite a bit of information missing that might be important. The other thing is, where is the sea ice measured? Is it measured just in the Arctic, in the Antarctic? The information here the graph doesn't state that specifically. So where was the ice measured? So the cons of this is basically the missing information. So let's take a look at another graph here. We've got a graph of the relationship between parents' income in 1988 and the children's income in 2008. So if we were to give an example of what one of these dots represents, this represents a family where the parents made approximately $90,000 a year, and the children also made $90,000 a year. So there is a relationship between the parents' income and the children's income. That's what this graph represents. The straight line that's graphed on top of all the points indicates that there is a linear upward trend. So as the parents' income increases, so does the children's income. So recapping that, the direction is positive or upwards. The form is linear. The strength, now notice how far apart the points are. If we were to draw a big circle or ellipse around this, these points are very far apart from the straight line. So that would mean the strength is weak. They are related. The parent income and children's income is weakly related. Outliers mean the points that don't follow the trend. You could argue that this point here is an outlier. So yes, there are outliers. This is an example of a family where the parents make $180,000 a year, but the children will only make $90,000 a year. So that does not follow the trend. And that is why it's called an outlier. So the source of this was the US government. So again, it's a reliable source, one would hope. The purpose is to find the relationship between parents' income and their children. What did I learn? I learned that there was a weak but positive relationship. This means that in general, as the parent's income increases, so does the children's. What I found surprising was the number of outliers, how many points there were that were really far away from the linear trend. So here's one, there's a whole group down here. There's a whole bunch of them that are quite far away or outside of the trend. So the number of outliers. So the pros is that you can see a trend. The cons is again the missing information. Who were the parents that were surveyed? Or who were the families? Were they rich area of the states? Or were they all in one state? What about education level? Did that have an effect on the relationship? So again, the cons I would say is the missing information from the graph. So let's take a look at how scatter plots can be used incorrectly. In this one, we've got a whole bunch of points, and what's wrong? Well, number one, we don't know what it represents. There's no axes. We have no context. There's no title. So it's just a whole bunch of dots. The next thing is that there's this negative slope that's drawn in, but really, because they're all scattered in a circle, we could have easily made the line like this, and it would have looked like it fits too. So these lines here that are drawn in, these three here, are deceptive. I say the points are all scattered about. There is actually no relationship between the two variables. And those lines that have been graphed on top of it lead you to believe that there is.